In this tutorial, we're going to be looking at the dynamic keyword, and the dynamic keyword looks something like this. But before we talk about the dynamic keyword, let's just step back a few steps. If you watched my previous tutorials where I talked about C#, the fact it's a strongly typed and also a statically typed language. So let me just talk about that for a second. A statically typed language is where the variable types, for example an integer for example, is known at compile time. And that's when I click this little green play button right here. The software compiles, and if there's any problems, the compiler will alert me the software won't compile. And this is a statically typed language like C#. This process is called static type checking. So static type checking. However, what if I told you that there was also something called dynamic type checking? So what is dynamic type checking? This is where the variable types, for example, are known at runtime. So if there's a problem with the types or anything like that, we can compile the software just fine. However, if there's an error, we won't know until the software is actually running. So what do I mean by all of this? Well, let's take a look at an example here. Here I have a sample integer. I'm initializing it to the value of 55. Then I'm just outputting it to the screen. So it's not really doing much. However, what if I want to maybe now assign a string value into this integer? So if I just type hello, for example, you can see there's an obvious error here. It cannot implicitly convert the string to an int. That's because the type of this variable is an integer. But what we're trying to do here is stuff a string into it, and it's not going to let us. So not only that, but our program will not compile. You can see there's an error here. And this is an example of the static type checking. It knows it's an integer, so it's an integer type, but now we're trying to put a string in there. But we're actually alerted of this problem right now in development. So this is known as static type checking. However, with something like dynamic type checking, then you won't be alerted of this error. Everything will look fine. The software will compile just fine. But unless you do something about this particular error here, you will be alerted about this error during runtime. So there are other programming languages out there, for example Python or Ruby. Now these are dynamically typed languages. That means, for example, we can do this and the software will compile just fine, it's no problem. However, you will be alerted about this error during runtime. So while the software is running, this is called runtime, and this is where the error may present itself. So at compile time, this is where C# can catch these potential errors to do with types, and that's called statically type checking. However, at runtime, in languages like Python, Ruby, then you will be alerted about these type errors, for example, during runtime, and that is called dynamic type checking. So now I've talked about static type checking and dynamic type checking and the differences. It's going to be easier to explain the dynamic keyword now. So under the hood, the dynamic keyword behaves pretty much like the object data type. If you watched my previous tutorials where I talked about the object data type, and it's kind of like considered to be the base class for all of the types. For example, the base class of double, integer, boolean, but not only that, but things like lists and custom objects and things like that. So if you remember and understand that detail about the object data type, then you're going to hit the ground running with regards to the dynamic keyword now. So let's take a look at an example. So what I'm going to do now is do an example with the object data type. So this variable here, called test, is going to be of type object. What I'm doing is storing a value here, 35.5, which could be a double, for example. It looks like a double to me. But there's no problem here because object is like a base class here. So it's going to accept that value just fine. But now we're trying to increment this value of test, which is data type object, by 7.5. So it looks like we're adding a double to a double, which should be fine. When we had it as double before, it worked with no problems. So you can see here, there's no problem. But now I've turned this into an object data type. There is a problem. So if I highlight this, it says operator plus cannot be applied to object and double. So when working with object, we talked about boxing and unboxing. So what I'm doing here, I have a simple data type here, 35.5, which is like a double, and I'm stuffing this into an object data type. Now, if you remember from before, this is a reference type, so it's stored in the heap area of memory. So what we're doing is boxing the value here into test. And when we try and increment the value, there's a problem here. We can't add 7.5 to this value here. What we have to do here when incrementing the value, for example, is explicitly convert this object data type to a type we can work with. So what we're trying to do is add 7.5, which is a double. So I have to convert this to a double. We can convert it to a double using the convert static class that we've been using all along in the previous tutorials. And that's going to work just fine. So what I'm doing here is unboxing the value. So here I'm boxing, here I'm unboxing. So there's a bit of a performance payload here when we do the boxing and unboxing like we talked about before, but it works just fine. So I'm converting the object to a double, then I'm adding a double to it, then I'm storing the value back into the object. So I'm kind of reboxing it again, and then I'm outputting the value. So if I run the program now, you can see I have the value 43, which looks about right. So you can see it works no problem. I can actually, add values together. I can even add 5 here, for example, and it's going to work just fine. So this is a bit of an advantage of using something like this over individual data types, but there is a performance cost. But the point I'm trying to make is when you use the object data type and you wish to kind of modify the values, you need to kind of do this unboxing here. You have to do an explicit conversion here. Now with the dynamic keyword I'm about to introduce, I said it's very closely tied to the object data type. It behaves very similarly, but we don't need to do this explicit conversion right here. And that's not the only difference. One of the main difference is that it provides dynamic type checking in a C# environment. So let's get started with the dynamic keyword. So the very first thing I'm going to do, so you understand it a little better, is to convert this example using the dynamic keyword. So what I do here, I define this variable as dynamic here. And because it's not the object data type and we don't need to explicitly cast anything, we don't need that cast right there. So if I run the program now, you can see it's working just like before. It's not complaining about adding a value to an object data type. So you can see there's a considerable advantage right here. We don't need to explicitly cast our variables, for example. So that's pretty good. And like I mentioned before, it works like the object under the hood. So it's almost like, the master base class that works with integers, booleans, and all things like that. So that's the first advantage of using dynamic. We don't need to explicitly cast anything. So we don't need to explicitly say, okay, make this an integer, so therefore we can now add an integer to it. Or make this a double, so we can add a double to it. We don't need to do any of that. It looks perfectly fine, look, so we've defined it as a double, now we're adding an integer to it. All of the conversion, casting, boxing and unboxing is done behind the scenes. We don't have any visibility of that, it's all done for us. So that's one advantage of this, that complexity is taken away from us. So watch what else I can also do, for example. So we initialize this as kind of like a double, and then we want to add an integer to it. Now, what if I say test equals hello, for example? So what do you think will happen now? So let's run the application. Well, it looks like we're outputting hello. So what I'm going to do, I'm going to add some breakpoints here. So we're going to enter break mode when we run the application, and then we're going to kind of analyze this variable test down here. So let's bring this up so we can have a better look. So right now, you can see we have a dynamic object right here, which is test, and it doesn't have a value yet because we haven't executed this line of code. Once I step over that, we can see that test is now a dynamic double because we've put a double value into it. Now we're incrementing the value by 5, which seems pretty fine. So you can see it's still a double. Now we're kind of trying to put a string value into here. So if we step over this, you can see now we have a dynamic string here. So you can see it's quite flexible in the way it works. It pretty much just throws out the whole concept of types, or at least hides the concept of variable types from you. So while developing applications, it may feel like all that complexity is taken away from you. You don't need to worry about, is it a string, is it an integer? So perhaps Python programmers, or if you've done some JavaScript, you might find this really useful. But however, errors can occur during runtime, and this is when your application is actually running. So there are a few problems associated with the dynamic keyword that you have to be careful with. So the dynamic keyword, it probably sounds quite great to you. We don't have to worry about types. We don't have to convert to different types. We can just use it for everything. Why not? And maybe there's a slight performance hit, but otherwise it seems pretty good, right? Well, let's talk about the downside of using dynamic right now. But first I'm going to introduce an example where we work with some custom objects. So what I have here, I have a video game class. It's quite simple. It has 4 private fields, a constructor, a sample method, and just a sample public property right here that just gets the video game title. So it doesn't do much. I've instantiated the class here. I have a video game object called game1. And if you followed my OO tutorials from before, when we make use of this instance here, we can see various things. We can see our getPublisher method, and we can see our property right here, the title. So we can see this. And when this window pops up here, this is like Visual Studio helping us. And another word of that is called IntelliSense. And what IntelliSense does, it just gives us some nice autocomplete features. It saves us from typing. For example, we can double click this, and then we have access to the method. Number 1, we know the method is there. Number 2, we know we can access the method. It's not private or anything like that. Number 3, if we double click it, we don't have to worry about typos, spell checking. So it's quite good. It also gives us parameter types we can use, and also lets us know about return types. So IntelliSense, otherwise known as Visual Studio helping us, is a very good feature, and I highly recommend using it. However, when using the dynamic keyword, IntelliSense is not available. Now there is a good reason for this, but it is one of the big disadvantages over using the dynamic keyword. Let's take a look at that now. So right now I'm just setting up a game here, then I want to get the publisher, for example. So let's just store that in a string. So I'll store it in a string called pub, and then I just want to output it to the window. So not much is going on here. It should output Blizzard, for example. So let's run the software now, and we can see Blizzard. So it looks like it's working just fine. Now let's turn this into a dynamic type. So now I have a dynamic object called game1. It has the value of the new instance of the video game class. Like I said, it doesn't have to be a double, an integer. It could be a complex type. It could be an array, a list, or even a custom class like the video game class. So absolutely no problem doing that at all. Fully supported by the dynamic keyword. And again, this is kind of like the object behind the scenes. So everything is fine so far. And if I run the application, we get exactly the same result. No problem at all. But watch what happens now. I put a dot after game1. You can see we've lost all of that IntelliSense. Visual Studio is now refusing to help us. We don't know what methods we have available unless we actually, kind of look at this and maybe copy and paste them in. However, it has a lot of problems this way. The thing is, it relies on us not to make mistakes. Number 1, like I said before, maybe this is a private method. So we can't even access it outside of this class. So therefore, we could create a whole big problem here. So if I run the application now, it's saying it's inaccessible due to its protection level. Well, what if I made a typo? What if I put F here? You can see it's not highlighting it red. I run the application, and it doesn't contain a definition. Well, that's because I spelt it wrong, and it's an accident. But I don't have Visual Studio helping me. I have zero IntelliSense. So this is one of the downsides of using the dynamic keyword. You have absolutely no IntelliSense at all. And IntelliSense is really useful, and a lot of people take it for granted, but it gives you all the methods and properties that you can actually use on an object. So you may be wondering, what was that sorcery before where you misspelt publisher and there was no red line? Why was that? What's going on here? Why was the program able to run? You know, that's normally not allowed. Well, yeah, that's true, because if I turn this back into a video game object, you can see we get the red line. And that's because at the start of this video I said that C# was a statically typed language, and that just means everything is caught at compile time. So I can't even compile the application because this is where the errors are caught. However, when using the dynamic keyword, then all of this has gone away. Nothing which is dynamic is caught at compile time. So the error is gone away. The program can compile. So the program compiles when the black window pops up, as you can see there. But now the error is actually caught at runtime. And this is the error that gets thrown. It's called a runtime binder exception right here. So runtime binder exception. So this happens at runtime while your software is actually running. So in a nutshell, when you use the dynamic keyword like this, Visual Studio just gives you free rein. It literally says, okay, do whatever you want. If something's dynamic, call any method you want, call any property you want. You know, it doesn't matter. I'm going to give you no red lines. I'm going to let you compile your software. You can do whatever you want to do. You can introduce human error. Pretty much you have free rein. So that's an advantage, or perhaps a huge disadvantage, of using the dynamic keyword. So the choice is yours in that regard. But programming languages like Python, Ruby, even JavaScript, these are dynamically typed languages. However, C# is a statically typed language. So you may be wondering, well, why does a statically typed language support this in the first place? You know, why do we even have this? I thought this was a statically typed language. Well, what if you want to create software that works with Python software, for example? If Python and Ruby are dynamically typed languages, then maybe my software needs to work with them. And a fancy way of saying this is called interoperability, or interop for short. So if I want to create software that works with someone else's software, but they used a different language, then this is where the dynamic keyword is actually quite useful. And even working with the document object model. Now this is something HTML and XML use. And when using things like that, you just do not know what methods and properties are available until runtime. So this is why it's quite useful. Not everything is known at compiler time when your software compiles. Sometimes it's only made available to you at runtime. So this is why the dynamic keyword is really useful. So a couple of fancy bits of terminology for you. If we have our simple video game object like we talked about before, and we wish to say call a method called getPublisher, then this is an example of what's called early binding. And that just means, okay, this method is available to us, we're using it right here. Any errors will be caught at compile time when we click this little gray button, and the binding is done early. Everything works, there's no error. For example, if I did this, then there's an error. Example of early binding. However, if this was dynamic and we tried to do this, right now we have no idea if this method is available. We have no idea if this method is public, private, internal, protected. We have no idea if I spelt it correctly. However, when I run the application, then the binding is done during runtime. So right now, okay, yes, the method is available. We've just called it. We've got a result. This is an example of late binding. So early binding before, late binding during runtime. So a couple of things you may hear in the future, but I thought I'd bring them up now. One other thing I didn't mention was dynamic. If you define a variable, for example, a simple integer or something like that, whatever you really want, the type isn't important. you don't need to initialize it. You can if you want to, there's no harm in doing that, but it's not required. You don't need to say, okay, this equals 5. You can kind of work this out later on. So that's another thing you can do with the dynamic keyword. So one other thing you can do with dynamic is even pass it into methods and return it out of methods. So I've just set up a sample method called echo, and it's just going to echo the value of the publisher, for example. So I know for a fact it's game1.publisher, which will get that for me. I have no IntelliSense, so I assume it's spelt correctly. And then we're just going to output that to the screen. Let's comment that one out, and then we'll call the actual method. So this looks pretty good. We're passing the game object in, which is dynamic, as a parameter to the method and echoing the result of the getPublisher method. Let's run the program. So it looks like it's working, you can see here. But not only that, like I mentioned, we can return the dynamic keyword as well. So here I am calling the method here that now takes no parameters. I'm initializing a new video game object and I'm instantly returning it, but I'm returning the dynamic keyword because I don't want a video game object. And then I'm catching the result here in a new dynamic game object, and then I'm getting the publisher. So you can see equally it works as a return as well. So dynamic you can pass around, no problem at all. So let's summarize the dynamic keyword right now. So the dynamic keyword, we don't have to worry about the types. We don't have to worry about casting types. All the boxing, unboxing, conversion is done for us. That's great. However, there's a performance impact. And again, we have to worry about spelling our methods correctly, working out if they're actually accessible, lots of different things. So in a nutshell, dynamic isn't used in a typical C# application. If you're just making a calculator or something quite simple, you shouldn't really use the dynamic keyword. However, if you're working with perhaps other pieces of software which have been developed in dynamic languages, or maybe something called a COM object or the document object model for HTML, this is where the dynamic keyword shines, and this is where you should use it. Because in instances like that, you don't have access to these methods at compile time anyway. You may only have access to them at runtime. So this is where you would use the dynamic keyword in this sense. So it's not used in common C# applications. So it's one of those weird scenarios where you never really ask yourself, should I use the dynamic keyword? It's usually presented to you. Okay, yes, this definitely looks like I should use the dynamic keyword. And that is what generally happens when you're architecturing a new piece of software, for example. So the dynamic keyword, it offers dynamic type checking, and it's basically the object data type, but on steroids. Thank you for watching. I hope it was useful.